All right, I decided to try and make my videos with Cami because I'm trying to encourage you to use Cami. So I'm going to show you how you can easily do this. Make sure you are always watching all of my videos with sound. Okay, you have to actually watch them. They have to actually have sound. We are sadly going to leave the ISN page blank. Okay, so we can, in Cami, you can use a text box, you can write. I'm just using a plain old cheap stylus, the kind you can find on the end of ballpoint pens sometimes. You can use your finger. I mean, there's a lot of options out there, but a cheap dollar store stylus would do the job here. And so this video might be a little bit longer because I'm going to throw in some Cami tips and, you know, kind of give you time to get through that. But I want to encourage all of you to actually try to do this in Cami, okay, along with me. That might mean that you are watching the video on your phone while you are doing Cami on your tablet, or you could split the screen, okay? And you can easily do a split screen and make it work that way. But you've got some options there as well, all right? Okay, so we're gonna start with a review of relations and functions. Okay, so this is a pretty basic review, but anytime we review over the super basic stuff, it's not because I don't think you know how to do it. It has more to do with notation and being specific about it. Just understanding it is one thing, but being able to communicate it correctly mathematically and read it correctly mathematically, that's important as well. Okay, so we have relations and functions. A relation, and I can type in here, so I'm gonna grab a text box. I'll make it blue. I'm just gonna click right there. So a relation is a set of ordered pairs. There's one way to define it. Right. So an example, and we can type our example too. So I'm just going to click down here, get a text box. And when you have a set, you're going to use the squiggly brackets. So it looks like that. It's right above the enter key. You have to use shift. And I'm going to open my parentheses. I get -2, 0, 4, 7, and 8, -12. There's nothing special about these points, just coming up with a set of them, okay? And remember, you are in control of this video. You can pause, you can rewind. I suggest that you pause before we do some examples so you can try them on your own before I just do everything for you. Okay, so there's different ways to represent relations. This first one, click right here. And if you of course, could be writing this with the stylus too. You don't have to be typing this. We will write as well. Table. This example is going to be mapping. That is a term that you should be familiar with, but I'm not sure all of you are. A graph and equations. So we'll get all this typed in and then we'll go to the examples. Okay, and if you don't like how it's centered in there, I mean, you don't really have time always to make it perfect, but I can drag it and center it. Like maybe do your notes and then go back and make it perfect if it bothers you. If it doesn't bother you, you can leave it, it's fine, but I know some of you that would bother you. All right, so in our table, I can just, again, either write, I don't know if the box is big enough for you to write in, but we're gonna make this 2, the y value. I'm gonna click over there. I'm gonna give you -2. This is 4. This is 0. This is 2. This is 2. 7, and 8, and 12. Okay, so there's a table of values that represents a relation. So remember that all functions are relations, but all relations are not necessarily functions. So I want you to think about whether or not this table of values would represent a function, and then we will come back and talk about that. Okay. So then we have mapping. So we're going to put 3 numbers in here vertically. We've got -9. I'm going to hit enter so it goes down below it. 0 and 2. And if you don't like the fact that they're not like in line with each other, if you highlight the numbers, you can go over here and center them. You absolutely do not have to, but I'm just showing you how to clean it up if that's important to you. All right, so and then in this one, I'm going to put 5, 7, and 9. Okay. All right, so mapping. We are mapping one number to another. That's if you're not familiar with that term from an algebra-based class, you should be familiar with that term from geometry. So I'm going to grab my pen. I'm going to use my stylus now. I'm going to grab the, what looks like a paintbrush, the drawing, and I'm going to choose pink. And then to get that out of the way, I'm just going to click on that again. So we're going to map -9 to 9. We're going to map 0 to 7 and 2 to 5. Okay, so my ordered pairs will be -9, 9, 0, 7, 2, 5, right? So think about whether or not this one would be a function. We'll come back to that after we talk about functions, or maybe probably before we talk about functions. Okay, so then a graph, right? So if I want to plot points, I could, most of the time you put your pencil down and you just kind of scribble in a circle, but it's going to be actually easier with the stylus. It's also going to be easier for me if I zoom in a little bit to make my graph a little bit bigger. So even when writing is tiny, you can always zoom in some. So I'm going to go over here and I'm going to grab my paintbrush and I'm going to change the thickness to 6. That way when I plot my points, I just have to literally, whew, that's a little big. Let me undo that. By the way, Control Z is going to be your best friend. Let's try 4. I think that might have been a little big. So I'm going to put my little point there. I'm going to put a point here. One here. Oops. Control Z, Control Z. It's my best friend. Okay. And those are supposed to be on the line. We can pretend. Okay. So then I want you to think about whether or not this would represent a function. Then we have an equation. We'll use y equals, oh, I could have changed my stylus back. I will in a minute. 3x squared plus 7. I'm going to change that back to 2 so I'm not always writing that big. Okay, so of these, 2 of them are functions, 2 of them are not. The mapping and the equation are both functions. You should know what this right here, what it actually graphs a parabola. These 2 are not functions, they're just relations because I have one x value that has 2 different y values, and same thing here, it fails that vertical line test. Okay. All right, so let's talk about domain and range. I'm going to go back to being able to type a little bit, which is nice. Click on my text box. So domain is your set of all possible x values. All right. Then here's how you can learn how to cut and paste. I highlighted all of that. I'm going to do Control C for copy. I'm going to click down here for a text box. I'm going to paste, and then I'm just going to change this to y, because your range is the set of all y values. Okay. Work smarter, not harder, right? So your x values represent your independent variable, and your y values represent your dependent variable. One drawback to typing in Cami is that we abbreviate a lot, and it usually doesn't like any of the abbreviations, but it's all fine and good. All right, so we're going to look just at of 1, 2, and 3. We're only going to do number 1. It says give the domain and range of each relation. So the domain, it's the set of all x's. So I'm going to make a text box here, my little squiggly brackets to get a set. And my x values are -1, 7, 3, and -5. And I want to put them in order from least to greatest. So that's going to give me -5, -1, 3, and 7. And then I close that. My range is going to be the set of my y values. So I open my set. And my y values are -1, 4, 0, and -1. -1 shows up twice, but I do not use it twice. I just have -1, 0, and 4. And there you go. Right? So this is set notation. There are different types of notation for domain and range. So over here in this blank spot, we're going to talk about the types of notation. Okay, so in here, we're going to say types of notation. Right. And then I'm going to draw a little graph. And so you need to draw this as well. Ooh, pretend like that's actually symmetric. That's supposed to be the parent function of a parabola, but again, you can fix yours if you want to make it perfect, but it's fine right now, as long as you know what it's supposed to be. Okay, so the first type of notation we have is what's called inequality notation. And I'm going to change my color. I'm going to make it, why did all my colors go? I don't have any greens or anything. Can't use that. Types of notation. Oh, I already wrote that. I'm a moron. I'm sorry. what I wanted to type was inequality notation. Right. And then we're going to look at the domain and the range. Oops, should be a capital R. Domain and range. So for this particular function, to do my notation, the domain of this function is all real numbers. How you write all real numbers in inequality notation depends on which textbook you look in, and some of them don't even address it because to actually use the inequality signs, you would have to use infinities, and you don't usually use infinities with the inequality signs, so it's kind of a weird little source of discussion, I guess. But we're just going to go with it's all real numbers. All real numbers is technically a set notation, but it's okay if that's what it is in inequality. We can, however, put the range in inequality notation. So I'm going to go back and grab my text box because I can type this as well. I'm going to go back in the text box I already had. And so let's talk about what the range is. The range goes from, the y values go from 0 to infinity, and we're including 0, which means that my y values are greater than or equal to 0. So I'm going to say y, and I want greater than or equal to. So up here at the top, this little f of x, I'm going to click on this. I want my keyboard for math, so I'm going to click on pi. And I've already used some of these, so they're up here, but I'll show you. It's right here. Y is greater than or equal to. Then I can type in 0. I typed in 0. You need to arrow to the right to get out of that keyboard, basically. And there you go. Y is greater than or equal to 0. Okay. Your next set of notation is actually set notation. Right. So we have for this domain and range. All right, so the domain is set notation. It's the set of all real numbers. Now, set notation has technically some extra parts to it. When you get into the deeper maths, you're going to have to add some other stuff, but we're just going to look at the basic set notation. We're really only going to use set notation mainly for finite sets, but you can use it for infinite sets as well. So here it's all real numbers. So I don't have that as a symbol. So I'm going to grab my pen again and say all real numbers. Okay. Then my range, grab my text box here. It's set notation. So I open the set, get back in this text box. I open the set with my squiggly brackets. And so we're going to say the set of all, it really should say the set of all y's such that y is a set of real numbers where y is greater than or equal to 0. But we're not going to put all that in there. We're just going to say it's a set of all y's such that, and that such that is actually a vertical line. So we're going to make 2 spaces so we have room for it. And then we're going to say y is greater than or equal to 0. So watch this. This already says y is greater than or equal to 0. So I'm going to grab this. I'm going to go all the way to the end, even though it's not highlighting it. Ooh, totally hit the wrong thing. I'm going to, okay, going all the way to the end, Control C, put it back over here, and Control V, right? And then I can close my set. For whatever reason, when you use the math stuff, it doesn't actually show that it's highlighting it when you highlight it, but if you go past it, you really will be. So what needs to go in here is a vertical line. So it's a set of all y's such that y is greater than or equal to 0. Okay. Then we have interval notation. This is the one we are going to use the most. You do have to be familiar with all of them though, because they could pop up where you have to be able to read it and understand it, but we're going to write stuff mostly in interval notation for the most of the year. So your domain and range. There will be times where we use some other ones for specific reasons. So back up here, my domain is all real numbers, but all real numbers is a set notation. Your interval notation, you're going to use parentheses and brackets. Well, all real numbers means I'm going from negative infinity to infinity on my x-axis. So that's what I need to put. So since we're using infinities, you always have open brackets, which are parentheses, when you have infinities. So I'm going to grab this, and I'm going to go ahead, because I know I'm going from negative infinity to infinity. I'm just going to go ahead and put 2 in. Oops, the wrong thing in there. I'm going to hit infinity, which is right here. I'm going to put it in there twice, and then I can go back over here and do what I need to do. So I really wanted that to be negative, so I arrow over negative infinity, comma, infinity, and then arrow out of that and close your parentheses. Negative infinity to infinity. Then your range, we go from 0 to infinity, so that's what we put it on our interval. But 0 is included, therefore we use a bracket. 0 to infinity. So I could copy one of those, or I could come back up here, and once you've used something, it's up here a little easier to find. Then I need to arrow to the right to get out of that so that I can close my parentheses. Okay, so that's a review of the notations. You should have learned all of them and be familiar with them. You may have spent more time on one than the other, but there they are. Okay, so we are going to, it says give the domain and range of each relation in inequality notation. So I want you to come grab your highlighter. This is your text highlighter, and we're going to highlight that inequality notation. I'm doing that with my mouse. It doesn't work with my stylus. There you go. Inequality notation. So use the right one. We're going to look at number 5. Right? So on number 5, my domain, I start here on the x-axis at -3, and I go to infinity. And I am including the -3 because it's a closed circle. So since this is inequality notation, I'm going to say that x is greater than or equal to -3. So I'm going to click in here with I need to grab a text box. And then I'm going to say that x, and then the greater than or equal to, I can't find on my actual keyboard, so I have to come up here to my math, and there we go, greater than or equal to, and I'm going to arrow to the right, -3. Okay, there's my inequality notation. Then I have y is my y values that start at -4 and go to infinity. So if you don't want to go back up there and grab the inequality sign, you can just copy this, Control C, open your text box, Control V, and then I can change this. You have to make sure you edit and you're not a victim of cutting and pasting. Got to change that to y and change this to -4. And there you go. All right, so let's look at number 6. Now these parts of this graph look like they might be going vertical, but they are not. They do not touch the x-axis and they do not touch 3, because we have something here, these lines that you should be familiar with. They're called asymptotes that exist there. So we cannot include those numbers because for this particular graph, it does not cross the asymptote. You can't think of asymptotes as lines that a graph never crosses, because you can totally cross an asymptote, and we will talk about that later. But in this case, for this graph, it does not. So my domain, I start at -infinity, keep going until I get to 3, but I don't actually get to include 3. So that means that x has to be less than 3. So I'm going to put that on here. I'm going to say that x, and then the less than you actually can get from your keyboard. It's not the official less than, but it'll work. Less than 3, and I have more. Then I start at 3 and I go to infinity. So x is less than 3 and x is greater than 3. All right. And then my range, I go from -infinity to 0. Then I start back over at 0 and go to infinity. So that means that y is less than 0 and y is greater than 0. All right. So now let's look at some interval notation on the next page. So give the domain and range of each relation in interval notation. Interval notation. All right. So I have the domain here. This looks like, maybe look like it stops, but it doesn't. Okay, it keeps on going. So my domain, we're going from -infinity to infinity. And when you think about it that way, that is your interval notation, going from -infinity to infinity. So I'm going to open my parentheses, and then I have, I'm going to say negative, and then I can grab my infinity, and I can go ahead and click infinity twice so that I can just get that done. Then I'm going to arrow to the right, Close my parenthesis, but I got to come back and put a comma in there. Okay. And there you go. We're going from negative infinity to infinity. My range, my y values start down here at -5 and they go to 5. So I'm going from -5 and 5. I am including them, so I need brackets. So I have my bracket, -5 to 5. Right. Now let's look at number 8. This is a line that has a hole in it. Okay, so if it was a line, it would just be all real numbers or from negative infinity to infinity, but I do not get to include this -1 in my x values. So that means that I'm going to start at, open my parenthesis, I'm going to have negative infinity. The more that you'll get quicker at coming and grabbing these things, negative infinity, and then to -1. But I'm not including -1, so it's an open bracket or parentheses. And then I have to start back over. When you're doing set notation, you have unions and intersections of sets. We have a union of these two sets, which means we're using both. It is not a capital U. It looks like a U, but it's up here again in you grab your math, or if you're writing it, just make sure you write it correctly. And here's your union and your intersection. So it's the union of the two sets. Union, and then open my parentheses, and I start back over at -1, but I'm not including it, and I go to infinity. And you never include the infinities. My range, so I start at negative infinity, go all the way up to -3. I don't get to include -3, and then from -3 on. So the only difference between my domain and range is the -1 changes to -3. So I am going to grab all of this. I'm going to highlight all this and Control-C, open my text box, Control-V, and then I go change this to -3. All right. So I want you to pause and do number 9. I'm going to keep going though. So you have to pause and do it, think about what it's supposed to look like, and then come back and see if you agree with me. Okay. All right, so the domain, I'm going from negative infinity to 0. I never include the infinities. I am including 0. So open parentheses, negative infinity to 0. And I am including 0, so it's a bracket. And then here I have, for my range, this keeps going, so I'm going to go from negative infinity to infinity. I already have that answer over here, so I'm going to come grab it and copy it so I don't have to retype it. Control-C, Control-V. There you go. Right, make sure you know the whys behind these. All right, so now I want you to pause and do number 12, and then come back and let's see if we agree. All right, so for number 12, I'm going for the domain. I start over here at -4, but I don't include it because it's open, and I go to 1. So I have an open parentheses, -4, and I go to 1. I am including 1 because it's closed, so that is a bracket. Then my range, so I'm starting down here at -7, and I'm going to 2. Now I realize that over here it stops right here, but even though it stops, and I don't get to, it's not including this y value, that y value is taken care of over here, and it keeps going. So your range is actually -7 to 2, and you are including both of them, so they need brackets. Okay, let's talk about functions. Okay, I want you to grab your highlighter. A function is a special type of relation. So I said it earlier, we're in special relation. So when we're taking notes, I underline a lot of things. I think it's going to be easier for us to maybe highlight them as we go. So a function is a special type of relation because all functions are relations, but not all relations are functions. Okay, so it is a special type of function. Grab your text box, in which each element of the domain, which is the x values, is paired with exactly one element of the range, which is your y values. Right? And so if you're not happy with how they went on the lines, you can move them a little bit. My aim was a little off. Okay, so let's talk about that. This is something you definitely should already know, but make sure you don't get it mixed up. This exactly one, that word exactly is super important, okay? Each element of the domain is paired with exactly one element of the range. That means for every x value, there is exactly one y value. So we should be able to identify functions from tables and graphs and equations. So let's see. It says determine whether the relation is a function. So I'm going to grab my pen. We'll use purple. All right, so if the relation is a function, then every x value has exactly one y value. And in this little table here, all of my x values have exactly one y value. So the answer is yes, this is a function. In 14, -9 maps to -2 and it maps to 5. So this x value actually has two y values. So this would be a big fat no. In 15, my x values, each one of them have only one y value, so it's a yes. Now, graphically, we have what's called the vertical line test. Your teacher may have called it the pencil test, but basically that means I can drag my pencil along or I can drop a vertical line down, and no matter where I do that in the graph, I should only hit it once. So in this case, this one is a yes. Here, when I drop my vertical line down, I hit it at 2 points, so that makes this a big fat no. And once again, this looks like they go vertical, but they don't. There are asymptotes right here and right here. Oh, I kind of missed that one. So when I do my vertical line test, then I am only hitting it at 1 point no matter where I go. So this is a yes.